So I got to be out of town for a couple of days. So instead of going live, I'm just going to provide a couple of recordings. One's going to be an extension of what we've been doing up to this point, and the other is making a pretty hard left turn and exploring a different kind of data and using our Linux commands to do so. But first, just to reiterate what we're doing up to this point is generating a codon alignment and producing a tree from it, right? Nothing more fancy than that. However, it's not uncommon to completely forget what you've done, have to back up, start all over, and remember what you have done in the past, right? So I'm going to pretend like that has kind of happened to me already. I'm going to remove everything that I've done up to this point except for my original DNA fast. Okay. And so now I can pretend like I've forgotten everything that I've done up to this point, and I don't know how to do anything. But we can combat that. And we can combat that by building a script. Building a script with all the commands that we've run, basically saving them so that we don't have to remember and type all the same commands over again. We can just have those commands saved in a script, run that script, and everything gets generated for us, right? Saves a lot of time, especially if you find a mistake, you can quickly correct that mistake, rerun everything, and everything gets stored. But before that, I'm going to introduce this new variable we haven't seen before, that's called the $path variable, or just called the path variable. It stores information. So in bash or shell or whatever, there are variables that exist, but we would call that information with the $sign, right? It's basically bringing the information that's stored in this variable. So another command that we're going to learn today is the echo command. Whoa, echo. And so echo is effectively a print statement. So echo hello world will just print hello world to the screen, right? So echo is basically a print statement. And so whenever I do echo $path, all capital letters, $sign in front, it's going to give me a long string of different directories, and mine's going to be a little bit different from yours. Some of it will be the same, but ultimately this is a colon delimited list of directories and the path to those directories that Linux reads and looks for programs in. So, for example, user local bin is a really common directory to store locally installed software to. But any user has access to user local bin. User bin is also the same. And then a whole bunch of others. So we see user local sbin, user sbin, opt ibuilt, tools, opt salmon, latest Linux, etc., etc., etc. And some of this stuff is local to me, right? So I can modify this path variable, and I have modified this path variable. So I've included additional directories for Linux to look through if I start typing a command. So if I start typing in, say, math, and I can tab over, and because Linux knows what I'm looking for. And it knows what I'm looking for because math is in a globally accessible directory. So, and I can demonstrate that with this which command. So I can do which math, and it's going to tell me that that math is in user local bin math. or sorry, it's in user local bin. And a lot of programs are in user local bin. So if I ls user local bin, hundreds of programs I have saved and written to user local bin. Most of these are mine. Some of them aren't all mine. But yeah, right, hundreds of programs in here. And we should note that user local bin, it starts off empty. Whenever you have a fresh install of Linux, user local bin is going to be empty. It's just populated with stuff that is going to be unique to the server, right? But a couple of global commands, even like ls, you can do a which ls, and it's going to tell me it's in user bin, right? Same thing with cat, so I can do which cat, user bin. So a lot of these global already installed programs seem to be in user bin, and anything that I create or I've installed is going to be in user local bin. Either way, both of those directories are in my path variable. However, right, what you've downloaded to this point, so bio 435, if you've downloaded that folder, that's not in your path, right? It's not in this path variable. So if you want to access those commands, you have to type out, for me, it would be home software bio, and then my program name, whatever it may be. Let's say translate. Translate's easy, right? And so that can be a little cumbersome, and it can be a little bit of a pain. But as I mentioned, I can change this $path variable, and I have changed it. And we can change this by going home, right? Now I'm in my raw home directory, and if I lsla, I'm going to have all of these hidden folders, right? We've kind of talked about this before. There are going to be hidden folders and files that are hidden from view because they start with a period. And so this bashrc file is a file that I can edit, and specifically I can edit my path variable to add directories that I have in my home to the path variable, so I don't have to type out its entire path every time that I want to call translate.py. I can just type in translate.py, and Linux will find it and run it straight from where it's located at. So unfortunately, I've already edited this, but ultimately, that line to add a new directory to the path variable is metaphorically export path, capital path, no dollar, equals $path, colon, and then this is not literal, this is figurative, but it would be path to new directory. Okay, so that's not, again, literal. If I'm making this literal and I want to add bio 435 to my path variable, how I do that is export path. Again, capital letters, no $, no spaces between path equals $path, no spaces. And then my POEM, for me, it's software bio 435. Okay, so that's going to be the command. Now, whenever I type in translate.py, it's automatically going to pull up. I don't have to provide the full path anymore. I can just type out the name, because now this software bio 435 is in my path variable, right? It's stored, it's saved, and I don't have to worry about it anymore. The thing is that every time that I log off, that export path command is going to be cleared. And so I can save this line, this export line, in my bashrc file so that it will run every single time. So anytime that I log on, Linux knows to look in my bio 435 for known commands or for all of those Python scripts or whatever else is in there, right? So that's going to be this export path equals $path software bio 435. The thing is whenever I do this, it's already written. So I'm going to do it again to demonstrate, but I'm not going to save it there because I have a pretty good chance of messing with my path variable. Now we have a new command to read and write to files, and so this will be handy in a second, especially when we start scripting. But that command to read files is nano. Now I'm not a huge fan of nano. I don't nano very often, but it is probably the easiest to use text editor in Linux. And so I'm going to nano that bashrc file. Okay, and so here's all of this stuff in my bashrc file. Now pretend like none of this stuff already exists, right? Just imagine that you don't see any of this. And as I mentioned, I can just paste this line in, export path equals path, new path, right? And so I can save this. So down here, whenever we see this up caret or this up arrow, up caret letter, that up caret stands for control. So if I want to, I've written to this, I'm done with this file. If I want to save and exit, that's going to, for me, it's going to be Control X and maybe Command X for you. So Control X, it says, yes, I'm going to modify this. This will destroy changes. That's fine. I'm going to save this. Yes, leave it as is, and it is done. Now pretend like you don't see the next couple of steps. As I said, I've already had this done, and I don't want to mess with my bash or I don't want to mess with my path, crap, I've done stuff. No. Okay, there we go. Okay, so I'm pretend like it's still there. Pretend like it's still there. I'm just deleting it. Yes. Okay. And so I pretend like I've saved this new path. Now, once you immediately do this, that doesn't mean the scripts in bio 435 are immediately accessible. So there's two ways to get access, is either to log out and log back in, or to source that bio 435 or that bashrc. So source the .bashrc. And whenever you run that command, now it's basically going to read that export path line. It's going to read that export path line and add any new directories to the path, to the $path variable. So I can type in just translate.py, and it's going to find it. Anything in my bio 435 now, it doesn't matter where I'm at in this directory. Doesn't matter where I'm at in my home. All of those scripts are available to me without having to type out home software by 435 and then a script name. So this line and using bashrc, it sounds really fancy, but this is, I would argue, this is still kind of like a low-level fancy command. We learned this kind of early. So whenever we start scripting, when we start getting better at this stuff, we don't have to call scripts from their home. And so like basically what this line is saying, this export path line is basically saying, make a new path, or sorry, it basically means path equals, really it's saying, I should say, it says new path equals old path plus new directory, right? That's effectively what it's saying. Whenever we do this export path, path equals $path, it's basically saying, take this all the directories in the old path, then add this new directory and save it as path. Roundabout, weird, awkward, I know, but super, super handy. Especially like if we're on a big server where we don't have access or availability to install software globally for everybody, right? If I'm at Texas Tech, or if I'm at Mississippi State, or if I'm anywhere that has a giant server or computer cluster that hundreds of people use, you can't edit anything in user local bin. You have to download and install software in your home, and then make Linux find all of that software for you. So kind of a requirement, kind of weird, but nonetheless usually a requirement in Linux, using Linux. All right. So I'm gonna now I have all those scripts available. So translate is immediately available. Reverse translate is immediately available. So now, and we've learned Nano. So learning Nano means that we can start scripting. And we've already started practicing scripting in R, right? We've made R scripts already. And so this isn't all that different. The commands are super, super different, I know, but this isn't all that different from typing stuff out into an R terminal and then saving those commands into an R script and saving the R script. So you don't have to type out those commands again. Effectively the same concept, just a little different because we're working on this weird server. So my whole goal of the past few days is to take a raw sequence file and build a tree from it. So I can go ahead and start scripting this out. And so I'm going to nano and make a new script name. So I'm just going to call this file first script. And like any good file, we need to give it an extension so that we know what this file is. And so a good script name, a good Linux script name or extension is a .sh. But it effectively stands for shell or bash or something like that. And so now we have this plain text file in here. And the first line of any good script is going to have this shebang line. And a shebang line literally is a hash and then a exclamation point bang. So we get the shebang. And the shebang line defines what program is going to read this script. And so whenever we type commands into the terminal, effectively what's reading those commands is a program called bash. And so bash, I think is in user bin, we just call bash, user bin bash. So that's the first line of any shell script, user bin bash. Okay, and now I can start populating this script with commands that I want to use. So for example, translate.py, pwee test.fast. Right, so that's already a command that we've seen before. And then saving this to a pwee align, aa.aln.fast, right? Okay, now our next command. Then so there's always a very good rule of thumb is to test each line before you go any further. Control X, save, yes, that's fine. Everything's fine. And so now we have that script there. I can cat it. And it has those commands in here. Now, to run this script as is, I would just call it as bash first script. And that should work. And so if that worked, now I should have a PWE align, or sorry, a PWE AA file that I want to keep, that has my translation in it. And so, yeah, and so I named it kind of stupid because I named it with an align, but I don't like that. But nonetheless, it should be a translated file as it is. Okay, yay. But I want to change that, so I'm going to get rid of it. And then edit my script. I just want to make sure that has a. Okay, and so if we recall, the next line is to create an alignment from the amino acid. So that's math. And so that's what we thread for any symbol pwe.aa.a.fast. I'm going to do one more line. That's the I'm going to have to call. I'm going to have to call it there because I kind of forgot the script name. Reverse translate. So I'm going to copy that so I don't have to type this whole thing out. Kind of annoying. My next line. And so that's going to be my aligned amino acid file. And then the raw DNA file. And save this as codon. pwe.cdn.aln.fast. Okay. Okay. And so whenever I bash this file, whenever I bash this first script, so yep, it ran. It should now I should have 3 new files. I should have my amino acid file, I should have an amino acid alignment file, and I should have a codon alignment file. And there they all are. Nothing is 0. If we see a 0, something went very wrong, right? And so we have to fix our script. Okay. And then the last line is the IQ tree. If I recall, that's IQ tree 2 -s. This codon line file, and I shouldn't have to do anything else, but I will still nonetheless put in a big T4 to run 4 threads, and that should be all I have to do. And it's fine. I can run this script again. All of those old files are going to get rewritten. It takes no time for that to happen. So I have no problem just running this bash script again. Okay, and now it's on to the IQ tree step. Right, it's the same output that we've already seen before, right? So I think it's nice to run the commands first and then recognize you can save all of those commands into a script that now, like if I delete all these files, it's fine because I have the script that can regenerate everything all over again and it takes no time for it to happen. Right, there's all of the IQ tree output that we've already seen before. And so the last kind of weird command, not super important because all of this works fine, but programmers and developers and me get really lazy really fast, and we don't like to type, right? If you notice, I don't type more than 3 buttons at a time before I hit tab because I don't want to type that much. I try to use as many shortcuts as I can so I don't have to type as much. And so for me, bash first script is too much text. I'm already typing too much. So if I want to type less, I can modify this file, right? So this script is currently a plain text script. It's only read and writable. And so we've never really talked about this RW, these file properties before. But it's kind of divided into like users, groups, and overall. So you, as a user, have rewrite access. Your group, which is still you, has read-write access. But if anybody tried to come in and look at came into your home directory, all they could do is read this file. They can't write to any of these files. And so I'm pretty sure that the order is you, the group, and then global or all. And again, we can change these properties. And we can change these properties using this command called chmod or change mod, chmod. And so with change mod, we can adjust the property. So we can make it, we can make this file read and writable for everybody that could be here. We can make it only read for me. That's kind of stupid, but if you're afraid of overwriting files, you can only make it readable and not writable. Or you can also make a file executable. And so if we look at our file for the 435, all these things are green. And all of these things are green because they have this additional X property. And so this X stands for executable. It means we can run it as a script. And so we can do the same thing here with this first script. I'm going to change it green. I'm going to change the properties to make it executable and turn that file green. And that command is chmod change mod u plus x and then the file name first script. Okay, and so now that file's green, that script is green, and I have an executable next to it. Now that's executable. So instead of calling bash and now this file name, I can just call this file name. However, this is a rookie mistake. I'm going to demonstrate a rookie mistake. You're going to try to type in first script. First of all, it won't tab over for me. I'm tabbing, it won't tab over. Recognize that's a problem. Script first script.sh. You're going to do this, and you're going to say command not found. Because Linux doesn't know to search in this directory for first script.sh. So if you want to have a script in this directory and run this script in this directory, what we have to do is call it from here. And to call a program or to call a script from here is period slash. We've seen this period slash before. It literally means from here, run first script. Now, if I type in first, it will automatically tab over because Linux knows to look in this directory for this script. And so I can just hit that. IQ tree complained. This is a weird thing about IQ tree, but because all of the output files have already been generated, IQ tree can take so long that you don't always want to start over. And so it's basically saying, hey, there are some output files here. I don't want to rewrite any of this. This may take a long time to rewrite. So you can, if you want to, you can have the redo option if you want to redo everything, or I'm just not going to do anything at all. Right? That's just an IQ specific thing. Recognize Maft went ahead and created a new alignment, but IQ tree said, hey, all this output's already here. I don't want to make this again. Right? And so yeah, so that's very, very basic scripting. Right, 4 lines. And that's all we did to get, that's all it takes to go from a raw FASTA file to a codon alignment and to build a tree based off of that codon alignment. And like any good script, we can comment it out if somebody's ever going to look at it. First, translate DNA to protein or amino acid. Next line, align amino acid. Create codon alignment. And build tree. Control X and yes, and now everything's done. So if I come along and look at this, or somebody else comes along, looks at this directory, looks at this first script, they can see what you've done. And I like doing this. I like leaving my scripts where they are. It's basically like leaving a note for myself. It's not just leaving a note for myself. It's a note that can do everything for me. I'm sure somebody could give me a reason why not to do this, but all of my files can be generated by this script in this directory. And so again, it's like making a note for myself. So I don't have to run these 4 commands over and over and over again if I want to. I just change the file names in my script, and it will just do it automatically. Now, if there's, I guess, one more command that we should figure out about IQ tree, I'm gonna have to look at a manual because I kind of forgot it. Let's see. It's using an ultra bootstrap. I think it's a big B. So nano for script in IQ tree, I'm going to add a big B, a dash big B option, literally a big B, and do 100. Right. So this is the equivalent of a bootstrap, but it's a little bit different to save a lot of time. It's literally called, in this help document, it's called an ultra fast bootstrapping method. IQ tree recommends that we should do 1,000, and that should be the minimum. But nonetheless, we're not here to do everything as we immediately should. We're here to learn how this works and provide examples. And so I don't want this IQ tree to complain again, so I'm going to get rid of everything that IQ tree would make, which is going to be anything that is this aligned FASTA and has a period after it. Anything that has a period after this file, I can get rid of. So I can do pwe cdn align.fast.star, or this asterisk. We've seen the asterisk before. And that's going to remove every file that starts with that prefix. And it should leave the raw codon file alone, because I'm asking to remove anything that also has a period in it. Yeah. Okay. All right. So that's gone. I can do my first script again, let everything run out. And something went, they complained. It said replicants must be over 1,000 or equal to. This is a weird kind of computer nomenclature, but that's greater than or equal to. So let's change that. Let's change that one more time just to make IQ tree happy. Okay. There we go. And it shouldn't take that long. We only have 9 sequences. It really shouldn't take all that long at all. Look at that, it's done. But now I should have bootstrap values in my tree file. Yeah. Let's see. Yeah, there's a bootstrap value. And so like in this Newick, that's going to reflect a branch length. So this branch, this platypus branch is so long, whatever this relative number is. But we'll also see the branch links, and then at an actual node. So this would denote a node. Having a closed parentheses is going to denote a node. And at that node, we have 100 bootstrap replicate, right? 100% support from the bootstrap. And we should see that again. There's our branch length, and we're at a node, and that's a bootstrap of 70. And so like these both branch links and bootstraps will be saved in this Newick, and any good tree reader will recognize that. All right, a lot of stuff today, I know, but slowly climbing that Linux ladder and going from not knowing how to run this thing at all to effectively flying it. All right, so I'm going to leave this one at that, and I'll see y'all later.